In this video, we cover short-circuit test used to determine the series resistance and reactance of transformers. We will also go through an example on how to use the results of open and short-circuit tests in coming up with the equivalent circuit of a transformer. This test is called a short-circuit test because we apply a voltage on one side and short the other side of the transformer. So here we have a transformer shown as an equivalent circuit referred to the primary side. So the side where we apply voltage is done such that the applied voltage is introduced gradually until such time that the current flowing on the other side reaches the rated current. Since the applied voltage is usually small to come up with a rated current on the other side, we can ignore the effects of the shunt circuit and use a simple circuit as shown here. So after applying the required voltage, we also measure the resulting current and the power consumed by the transformer, including the voltage applied. And based on this circuit, this is just a simple a series circuit. We can apply KVL there, and that will give us this equation in a phasor form. This will be the equation. We can combine these first two terms and rename it as this one. And likewise for these two last terms, we can combine that to become this term. Using the magnitudes of the phasors, we can actually write this relationship to determine Req and Xeq. We need another equation, and that will come from the reading of the power. So this reading must be equal to the power consumed by Req. Take note that Req is the combination of R1 plus A squared R2. So using these two equations, we can solve for Req and Xeq as shown here. So let's have an example to show how to manipulate the results of an open circuit test and a short circuit test. We won't be doing an actual test, but here we're just given the results of the test, and from these test results, we'll come up with an equivalent circuit. So here we have a transformer, a 100 volt ampere transformer, a step-down transformer with a turns ratio equals to 2, and we are required to find the equivalent circuit referred to the low voltage side. So here is the setup for the open circuit test. So we apply voltage at the primary side, and since this is exactly the setup that was used to derive the formula, we simply copy that formula to solve for R sub C and X sub M. So here is the formula. So we have A equals to 2 and R sub C. So this is the formula, and that will give us that value for R sub C. So R sub C is usually large relative to the series resistance and reactance. Also for X sub M, we can compute that using the formula, and that will give us 4.4 kilo ohms. So X sub M is also usually large compared to the series impedances. For the short circuit test, this is the setup. So we apply the voltage on the primary side and put a short on the other side. So this is the result. Since again the setup is the same as when we showed the derivation of the formula for the short circuit test, we simply copy the formula, and so here is the equivalent series resistance. So Req is 0.503 ohms, and for Xeq we get 1.9 ohms. So for the equivalent circuit, we first use the approximate equivalent circuit of the transformer referred to the primary side. So here we already have a value for Req and Xeq. So these are the values. And then we translate those values to the secondary side to come up with the equivalent circuit referred to the low voltage side. So this is the equivalent circuit. And these are the values of the parameter. For Req prime is 0.13 ohms and Xeq prime 0.48. RRC prime is 3.39 kilo ohms, and X sub M prime is 1.1 ohms. So that's it for this video, and for module 1 covering transformer principles.